Right, today's lecture is about the problem of induction, um, which is introduced by David Hume way back in the 1700s. Then we're also going to talk about Staley's uh, account of it. So you can get to this problem, you can sort of like state this problem in a few different ways. So we're going to tackle it in two different ways, and hopefully one of them makes sense to you. So we'll start with David Hume. So David Hume was a Scottish philosopher. I lived in the early 1700s. Kind of the way philosophy happened back then was you kind of had to be rich. I don't think he was like super rich, but he did sort of have the equivalent of a trust fund that helped him sort of get by writing philosophy for a while. And he wrote on really an astonishing amount of subjects. He wrote history, he wrote ethics, philosophy of mind, and he'll come up many times in this course in philosophy of science. Started pretty young. He started writing his most famous book at age 23, but he was really pretty radical for the time. He was basically an atheist, or he was very skeptical of religion and really skeptical of everything. But it was this skepticism about religion, miracles, things like that really kind of got him in trouble. And it was very difficult for him to find a steady job because of that. So as I said, he was largely a skeptic, not because he was just like mean or a bad guy or anything like that. But the idea was he wanted to look at all these things that people have sort of assumed, that they knew the answers to, and he wanted to sort of just like double check the reasoning and make sure that there was some rational basis for the claims people were making. And he found that it turned out with most of these things, there really wasn't any rational foundation for it. So in this case, what he's wondering about, right, is how we come to know what he calls matters of fact. Um, so what he means by matters of fact, he sort of contrasts it with relations of ideas, right? And we'll, on the next slide, we'll talk about what those two types of things are. But basically, any kind of fact out in the world, right? And mainly he's concerned with sort of general facts. So one of his examples is bread is nourishing, right? So he wants to know how, in general, you can know that, if you eat a piece of bread, it will give you nutrients and you'll feel full and all that stuff. He's a little bit less concerned with like particular observations, right? So I can say that cat is black, and that stuff he seems to largely be okay with, or at least he doesn't talk about it too much. That stuff you can know just from observation, but his question is, how do you go from your observations of particular things to these more general claims about bread in general or cats in general, right? And this is of interest to us in philosophy of science because this is what philosophy does. It makes general claims. We're not trying to just understand why one particular cat is black, right? Or what one particular loaf of bread is like. We want to know more general things so that we can explain them, and then we can predict them and manipulate things that haven't even happened yet. So we want to have understanding of stuff that it isn't even happened yet, so we can predict it and so on, right? Okay, so let's get into his argument here. So Hume starts out with this distinction between matters of fact and relations of ideas. And he says these are the two types of things that you can know, right? They're all going to fall into the category of one or the other. So this isn't in his passage that he wrote, but let's take this example, and that might help us get an idea of this distinction between matters of fact and relations of ideas. So if you've ever taken a philosophy class, you've probably heard this argument, right? All humans are mortal. Socrates is human, so Socrates is mortal. So this is sort of an example of reasoning, right? We have a general claim about humans. We find out some information about Socrates, and then we can draw a conclusion, right? Oh, Socrates must be mortal, right? So where are the matters of fact in this, and where are the relations of ideas, right? It's just in this example. Well, all humans are mortal. That's a matter of fact, right? So that's a truth about humans. It's one of those general truths, right? And then we have another matter of fact, Socrates is human, and that's a particular matter of fact, right? And from those, we can then deduce another particular fact that Socrates is mortal, right? So all three of those premises are matters of fact. So where do the relations of ideas come in? Well, they come in is the relations between those matters of fact, right? So here, again, here's our argument, right? So how is it that we can conclude that Socrates is mortal? Well, we know something about what all means, right? When we say all x's are y's. And we know what is means when we say Socrates is human or, right, that cat is black. And the idea is that the relation between all these words, right, between like what we mean by all statements, what we mean by is statements, and when we attribute them to Socrates or humans, right, those relations, those entail that Socrates is mortal, right? And that all comes sort of a priori, right? Once we have those two matters of fact that humans are mortal and Socrates is a human, we don't then have to examine Socrates to see if he's mortal or wait till he dies or whatever, right? We know just from the concepts of being human, right, being mortal, being Socrates, is, and all. Those concepts together allow us to draw the conclusion. So that's the relation of ideas. You can sort of think of it really as relations between concepts. And relations of ideas, you don't have to really interrogate the world, right, to know those. So here we go. This is sort of, you're going to encounter in this course, at least in the readings, a bit of sort of formal logic. And I'm going to help sort of walk you through it and make sure that it makes sense to you when you first, if you haven't taken a logic course before, particularly if you haven't taken sort of the higher division logic course where you do this sort of stuff with these upside down A's and stuff. It may not make sense to you at first, but it's relatively simple, so I'll walk you through it. Don't freak out when you see it the first time. So here's the argument, right, with everything stripped away except this symbolization. So the capital HX, right, so that means X is human, right? So plug in anything for that X, right? So call little s Socrates, right? So if I say HS, that means Socrates is human, right? If Nate was little n, HN would mean Nate is human, right? And then MX means X is mortal. So right, capital M, little s would mean Socrates is mortal. So that's sort of how that convention works. It's applying a property. So the capital letter is the property, and the small letter is the object that we're attributing the property to. So in premise one here, we have this upside down AX, and that means for all X, right? For anything in the world, this says, if it's human, arrow means it's an if-then statement, right? So for everything in the world, if it's human, then it's mortal, right? So that, in logic language, is the translation of all humans are mortal. Line 2 here, we have HS, that means Socrates is human. And then, so those two are just the two matters of fact, right? And that's what we call them premises. We know those purportedly by looking at the world. Now we're going to get into more about how you could know number one just by looking at the world. That's Socrates is going to have some questions about that. Not Socrates, sorry, Hume is going to have some questions about that. But anyways, those first two, supposedly, you're supposed to know just sort of from experience. Those are matters of fact. Now, line 3, we take line 1 and then we just plug in Socrates, right? So if it's the case that all humans are mortal, then it must be the case, right, that if Socrates is human, then Socrates is mortal, right? So that's a relation of ideas, and that's a rule of inference we call universal instantiation. If you have a universal rule like 1 there, you should be able to plug in any object for it, for the x's there. And then line 4 also comes to us just by the relations of the ideas, right? So that comes from line 2 and 3. It's modus ponens. It says, if Socrates is human, then Socrates is mortal, right? Well, we know that Socrates is human from line 2, so that spits out Socrates is mortal, right? That's how if-thens work in English. And that rule is called modus ponens. You have to memorize these, but sort of like getting you used to these sort of arguments because you're going to run into them in these readings. So again, yeah, not a logic course, but so the first two premises, again, are matters of fact. The second two come from relations of ideas. Okay, that's just what I said. So again, yeah, let's move on to the next slide. So again, I guess I sort of like talked through all this before I got ahead of myself with these slides. But again, yeah, line 1 and 2, matters of fact, all humans are mortal, Socrates is human, and then lines 3 and 4 you get from the relations of the ideas. If you understand what all means in line 1, then that means I can plug in any object, right, and it should come out true. And then modus ponens says if I've got an if then on line 3 and I have the if part, then the then part should follow. If it rains, the streets will get wet, and I know it rained, then I don't even have to look out the window. I know the streets will get wet. Okay. So where do we get these relations of ideas from, right? How do I know those are true, right? How do I know universal instantiation and modus ponens are good rules of inference? That's a really good question. And in fact, there are deep sort of philosophical questions about that. But the way Hume approaches it is that relations of ideas are true when the contradiction of them, or to deny it, would force you into a contradiction, right? So it's the sort of thing like saying 2 + 2 doesn't equals 4, right? That's just contradictory. That's just insane, right? Or if I said all humans are mortal and Socrates is human, but he isn't mortal. When you hear that, you should think you're not thinking straight, right? That's just contradictory. You just said, right, that all humans are mortal and Socrates is human, so it has to be the case, right? Mortal. Um, so, anyways, that's the idea Hume will use over and over again. It says if we're talking about a relation of ideas, we'll know that it's a relation of ideas if denying it sounds contradictory to us. Otherwise, if you can deny it and it doesn't sound like a contradiction, then that will be a matter of fact. So if I said Socrates isn't human and you didn't know who Socrates was, right? It wouldn't immediately strike you as contradictory. Maybe Socrates is my cat, right? Um, so again, matters of fact, you could deny them and it's not contradictory. Relations of ideas, to deny them is to contradict yourself. Okay, so Hume accepts relations of ideas. He thinks that's perfectly good reasoning, right? So what he's really worried about are these premises. How do we know that Socrates is human? And he actually is not. That's an interesting question, but he's not too worried about that. I think that he doesn't say it in this passage, but from what I know of Hume, he thinks that you could pretty much figure out by looking at Socrates, right? Socrates is human. But he's very interested in how could we possibly know this general statement, all humans are mortal, right? Um, and it's how do we know that's true? And he says, well, it's not a relation of idea, right? It's not a contradiction, right? It's conceivable that there might be an immortal human, right? Um, I mean, and in fact, in reality, right? Yeah, it's not sort of like totally impossible that depending on how you define human, maybe you upload my brain into a computer, and if you still want to call me human, then I could live forever. Or maybe we just cure all the diseases, right? Maybe you just keep replacing my organs. Maybe not human. So, anyways, it's not a contradiction to say that not all humans are mortal, right? So it's not true because it's a relation of ideas. All humans are mortal is some kind of matter of fact. Um, and here I have just another example, right? This is one because maybe you probably don't know this. So if I told you, oh, all beetles have a reticulated thorax, right? Maybe you don't know if that's true or not, but it doesn't sound contradictory like right off the bat, right? So even just by hearing it, you know that's a matter of fact, right? Not a relation of ideas. So hopefully that distinction is clear. And the question is, how do we come to know general matters of fact, like all humans are mortal? Now here he makes a little leap, Hume, and I don't want this to be sort of a whole lecture about like Hume's scholarship or like interpreting Hume, right? Now, certainly there's courses that will do that in our department, and they're very interesting, right? If you're into that stuff, and you can even write a paper on that sort of thing, right? So here we're just going to believe Hume. We're going to just take him at face value, even though it's not obvious, right? So Hume says matters of fact are fundamentally all facts about causal relations, right? So when I say all humans are mortal, I'm making some claim, some causal claim. Again, that's not obvious right off the bat, right? And you can read, do a lot of reading, and people are going to like sort of try to explain that for you, what he meant, right? But maybe what we mean is this, right? Something about being human causes you to die eventually, right? That's the claim. So, right, and I guess that's plausible. Let's just go along with Hume here. So rocks don't die, right? So something about rocks. Humans are different than rocks in that there's something about us that makes us die, right? And actually, the more we learn about it, there is sort of programming into your DNA what's called sort of like senescence, right? You do have sort of genes that turn on that make you start to deteriorate, and not actually all animals have it. Some fish and birds don't. So plausibly, there is some sort of causal story to be told about why all humans are mortal, right? And in general, so um, again, he doesn't really offer us an airtight argument for the claim, but it's plausible enough that if you're talking about a matter of fact, particularly these general kinds of matters of fact, you're talking about a causal relation. So let's just go along with that, right? So we got our generalizations. All humans are mortal. Another sort of generalization that we use in science, right? All objects fall towards the Earth at 9.181 meters per second squared. And these are, plausibly causal claims. Right? So the next question Hume wants to ask is like, okay, so if it's true that he wants to know, how do we know about matters of fact? He says, well, there are claims about cause and effect. So the obvious next question is, well, how do we know about causes and effects, right? How do we get that knowledge? And your first guess might be, well, by observing it, right? We observe humans dying, we observe things falling towards the earth. But Hume wants to stop you there, and he says, actually, well, be careful here. Are you seeing the causation, right? Or are you just seeing a human and then later they're a dead human, right? Are you seeing an object in the air and then later you see an object on the ground? You're certainly seeing series sort of events, right? But are you seeing causation, right? And he says, here's the difference, right? Here's how I know you don't actually see the causation part. You're not observing the causal relationships. He says, if I just showed you like a pile of gunpowder and you'd never heard of it before, didn't know what it is, right? You couldn't look at it and know that it was going to explode, right? If you lit it on fire, right? You don't see the causal powers in the gunpowder, right? You just see the gunpowder. You come to believe it has a certain causal power because you come to see that if you, right, apply fire to it, it explodes. That's not something you observe. That's some inference that happens later on. Same with water. Just by looking at water, you might not know that, right, if I dropped you in a large bucket of it and put a lid on, that you would drown. And this is sort of where we end up with part one of this reading, right? We get to, okay, how do we know matters of fact? Well, they're causal claims. How do we know causal claims? Not by observing them, right? You don't see causation. Okay, so moving on. So if we don't observe causation itself, right, maybe there's some other way that we come to know these causal claims. Right? Maybe it's by observing a series of events, right? So we do observe over and over that like people eat bread, they get full, they tend to grow and not die, right? So you might think that's us observing that bread is nourishing, right? At any rate, we have observed, right, in the past that every time someone eats bread, they are nourished. Right? So does that justify us in believing the claim that bread causes nourishment, right, always and for all time, right, or that all bread is nourishing, right? Just because we've observed these things in the past, is this the same as observing general causal relationship? Uh, and Hume says no. Again, you don't observe the causation, right? You observe the superficial qualities of things. You see the color, right? The texture, and but you don't observe, right, that bread is nourishing just by looking at it. You see that it's brown, crusty, and so on. Um, so what you're doing is you're seeing these superficial qualities, and you're making some kind of inference from those to some unobservable sort of nutritional quality based on your past experience that every time bread has been eaten, the person who ate it has been nourished, right? Um, so what sort of inference is this, right? There's an inference involved, right? Since it's not direct observation, which is fine. Some inferences are fine, right? Um, and in fact, what we call demonstrative inferences, just like the one we made with Socrates, right? So that in deductive logic, right, you have these guaranteed sort of airtight sort of inferences you can make. If A, then B. A, therefore B, right? Can't be false. Is always a good inference to make, right? So the question is the inference, the sort of inference we're making from the superficial qualities of bread and our experience of seeing people eat bread and then be nourished, is that like an airtight inference to the next loaf of bread I see? Is that going to be nourishing as well? He says, well, no, because bread is not nourishing isn't a contradiction, right? Those sort of demonstrative inferences, those relations of ideas, we can recognize those because to deny it is to contradict yourself. But to say bread is not nourishing is actually not to contradict yourself, right? That's possible. I could conceivably make a bread that's mostly sawdust and it would not be nourishing, right? It happens most of the time to be false. So, but false isn't the same as contradictory, right? Okay, so there's some kind of inference involved, right? When we make these causal claims based on observation and experience, but it's not a demonstrative inference, right? So what the heck kind of inference are we making? Well, it's not right about relations of ideas, right? It's not that kind of reasoning. So it must be about matters of fact, right? So, but now we've caught ourselves in a loop, right? So our matters of fact are based on reasoning about cause and effect. Reasoning about cause and effect is based on some sort of inference. What kind of inference is it? Well, it's not inference based on relations of ideas, so it must be based on matters of fact, but that's where we started in the beginning, right? So this is really Hume's argument, is that if you're trying to justify your knowledge of general claims about matters of fact, you're going to be caught in a circle, right? We just don't have, as far as he can tell, any rational basis for making these claims, right? Um, so that's Hume's argument in the passage you read. Now I want to go on and cover Staley's treatment of the same subject, because I think he approaches it in a slightly different way that will help you see the problem from a different angle, and hopefully will make it click for you if it hasn't clicked so far. Because Hume is a tough read, right? It's written like hundreds of years ago, and they were almost speaking a different language back then, even though it's written in English. Okay, so here's Staley's account of the problem of induction. So he talks about this guy Zig and the horseradish donut, which you'll remember if you read it. He adds a couple extra layers to this because he's got some other points he wants to make about the issue of falsification, right, which is sort of Popper's solution to the problem of induction. So that's sort of loaded in here, but it shouldn't be a problem. It'll all make sense down the road. So here we have this guy Zig, right, and he's just he loves donuts. He's a donut freak. And he has come to believe that the general rule that all donuts are delicious, right? So let's call this law the law of donut delectability. And then one day, right, Zig strolls into his favorite donut shop, right, for his usual 6 donuts that he eats every day. You see they're advertising a new type of donut, a horseradish donut. Zig says, well, never tried that, and I love donuts, so let's give it a shot. And he tries it, and woo, it's disgusting, right? Not good. Okay, well, this sort of like blows Zig's mind, right? He loves donuts and is convinced of the law of donut delectability. So he's not just going to give that up right away, right? He's going to be a little tough to convince that horseradish donuts are in fact disgusting. So on this subject of horseradish donuts, he's sort of a Hume type character, right? He's going to be very skeptical about how is it that we can prove that in this matter of fact that horseradish donuts are disgusting. Now he only ate one, right? So I don't think anyone should be convinced of a matter of fact necessarily, right, after just one try. So he goes to a bunch of donut shops, eats a dozen at each shop, 239 more horseradish donuts, right? Guess what? All of them disgusting. However, Zig, very, very skeptical. Nonetheless, he is not convinced, right? You still think, well, it's possible that the next horseradish donut will actually be delicious, right? And after all, right, it's not a contradiction to think that it will be, right? If you had never heard of horseradish, right, and I told you horseradish donuts are delicious, it's not obviously contradictory, right? It's just a matter of fact that may be true, may be false. Right? So it may be true or false that the next, even though he's had 239 terrible ones, it's not inconceivable the next one would be good. And Zig is technically right? We haven't offered any sort of deductive proof that horseradish donuts are disgusting. It's not as surefire as the way we prove that Socrates is mortal, right? What we've offered is an inductive argument, right? So here's the first time I've actually used this word induction, right? Notice in Hume, the word didn't appear, even though we're talking about the problem of induction. So deductive arguments in logic are the ones that, if the premises are true, the conclusion guaranteed to be true, can't be false, right? Because these rules of inference, like modus ponens, they're airtight. They will all, you feed in true premises, you will always get a true conclusion. Induction, a slightly different thing. It's a sort of argument where you go from individual cases. I tried 240 horseradish donuts, and then I make a bit of a leap, right, to a more general claim where I say all horseradish donuts are disgusting, right? So this sort of reasoning is called induction, and it is not as rock solid as deduction in that it could always turn out that the conclusion is false. Okay, and this, again, is Hume's question. How is induction justified if it's always possible it could provide a false conclusion? So what is it? What's the rule, right? Flesh out the reasoning for me, right? You've made this deductive leap, but you're not convincing me. What's in the leap, right? What justifies the leap? And this is the problem with induction. One way you might think to approach it is say, well, we could make this inductive argument into a deductive argument if we just had one extra premise, right? Let's call that premise the principle of uniformity of donut properties, right? PUDP. And this says that all donuts of a given kind will resemble each other in taste, right? So all horseradish donuts will taste similar to each other, right? And all strawberry donuts will taste similar to each other. If we could assume that principle, then having tried 240 horseradish donuts, we could assume, and in fact, having tried one, right, we could assume that the next horseradish donut would taste like the other ones, disgusting, right? Okay, but the question is, so that would be great if we had that premise, then we wouldn't have to do induction. We could just do deduction, right? It's basically, yeah, it means we don't have to worry about induction. The problem is, how do we convince Zig of that premise, right? Again, he is a very skeptical person, right? So he's not just going to buy this principle of uniformity of donut properties just because we say so, right? We need to say why he should believe it. And now here's the problem. The best we could do really is offer an inductive argument. Like millions of people have eaten billions of donuts, right, over the course of history. And by and large, all the strawberry donuts tasted the same to them, more or less, right, or very similar. All of the caramel donuts tasted very similar. But again, that's just an inductive argument, right? It's always possible that there could be a strawberry donut that tastes nothing like all the other strawberry donuts, or at least it's not a contradiction just to think about it, right? So Why in the world would Zig believe that? Well, we could not worry about inductively proving PUDP if we had another premise, right? And that premise was something like the principle of the uniformity of food properties, right? So in general, certain types of food all taste the same, right? So spaghetti with meatballs tastes like spaghetti with meatballs, right? And uh, baked salmon tastes like baked salmon, right? Every time you eat it, more or less. And then from that, you could deduce that all donuts will taste the same. And then from that, you could deduce that all horseradish donuts will taste the same. And then you could deduce that since one horseradish donut is disgusting, all the other ones will be disgusting, right? But you may at this point have guessed that Zig is going to have trouble accepting this principle of the uniformity of food properties as well, right? He's going to be skeptical about this, and you say, why should I believe it? And again, we seem to be stuck in an inductive argument. Well, it's just, billions of people have tried billions of types of foods, and the same types of foods seem to taste the same. But again, always possible that it could turn out false, right? There could be one spaghetti and meatballs that tastes very different from every other spaghetti and meatballs. So we seem to be stuck in the same problem, right? Now, you might think we could have a master premise called the principle of the uniformity of nature, right? And this says things are always going to happen in the future more or less the way they happened in the past, right? Things fall towards the Earth at 9.81 meters per second squared. They always have, and they always will, right? And that would give you, now you could turn any sort of inductive argument into a deductive argument, right? So I could say, well, I have observed that black cats all like cat food, right, in the past. And so given the principle of the uniformity of nature, right, all things observed in the past will tend to continue in the future in the same way. And so I can then deduce, right, that all black cats like cat food. And they will always in the future, and then we can predict, right, the behavior of black cats. But the problem is, right, what evidence do we have for that? And this is sort of Hume's final sort of question to you. And we all, every day, we just assume this, right? Well, yeah, if stuff happens, if you observe something happening the same way in the past, we assume the future will resemble the past. And Hume says, why, right? What right do you have? What evidence do you have that the future will resemble the past? And you might say, well, in the past, right, the future always resembled the past. And he says, that's exactly the question. That's exactly the issue, right? That I'm asking you to prove, right? So you can't convince me that the future will resemble the past just by saying the future has resembled the past, right? That's the question that I'm asking you to convince me of. So again, this is maybe a larger circle, right? I'm drawing a little bigger circle than Hume did in his own passage, but it's the same point, right? Which is that ultimately if you're trying to justify inductive claims, right, inductive reasoning, you can't do it, right? You have to keep pushing back and back, and eventually you're going to come into a circle where you're trying to prove that the future will resemble the past on the basis of the future resembling the past. Right? Okay. So just to drive it home, let's talk about a particular example, right, in science. So here's Newton and his theory of light. So Newton wanted to prove that sunlight is actually composed of rays of sort of like different wavelengths, right? If you've ever run light through a prism, you'll see that it spits out red, orange, like a little rainbow, right? So those are all sort of packed into the white light, but you can kind of split them up. And what he wanted to prove is that those different wavelengths of light refract at different angles, right? If you send them through a prism, and you see in this picture here how the purple is bending a little more than the red does, and so on, right? Anyways, that's what Newton's claim was. So this was not the accepted view, right, at the time, right? They thought there was just kind of light was just sort of a homogeneous thing, right? And so Newton wanted to prove this, right? So the accepted view at the time then would predict that if you took the sun, right, which is in the upper right over here, and you sent it through a prism, right, and projected it onto like a background, you just get a little round dot, just like the sun, right? But Newton's different theory predicted that in fact you would get an oval, right? Because the different parts of the light would refract at different angles and it would spread out. So Newton does it, and in fact he does get an oblong image. He gets an oval, right? But Newton, sort of like Hume, right? Newton wasn't satisfied doing it just once, right? That wasn't enough evidence for him, right? He wanted to make sure that it would always happen the same way. And so he did all kinds of sort of modifications. He used different prisms in case, right, the issue was like he just had a messed up prism. He double checked and aligned the angle very carefully to make sure that was set up just right. He even did sort of a totally different type of experimental setup, right, where he used two different size holes so that he could project like sort of the red light through. And in each case, right, he found that in fact his prediction was true, right, and that the old theory was wrong. So here's the second setup he did, right, where he runs it through the prism, through a hole, and then through another hole, and then through another prism, right? So in the end, he made a general claim about the nature of light, right? So somehow, at some point, Newton was satisfied, right? He was not skeptical all the way to the end in the same way that Zig was, in the same way that Hume was, right? So he did have concerns, and there were a few things that he needed to make sure of and prove so that he felt like he could make his inductive generalization to his general claim. But once he was satisfied of those things, that his experimental setup was right, that his prism wasn't messed up, right, and so on, then he felt comfortable making the general claim. So it seems like in practice, scientists are very worried about certain sort of issues in their inductive generalizations, but they're not worried about induction in general in the same way that Hume was. So this is just what I said, right? So these are the things he was worried about. So this is just sort of interesting. What's the difference, right? So Hume, right, might say, well, did you try doing the experiment on Wednesday, right? Because maybe it's different on Wednesday than Tuesday. Did you try the experiment in Paris as well as London? You never know. Could be different in Paris, right? It's not a contradiction to say that light behaves different in Paris. So, like, shouldn't you check that out? And Newton certainly wasn't worried about that. And in practice, right, scientists are not. So, very interesting. What is this difference, right? I'm not going to answer that right now. Might be something you might be interested in talking about in your paper. I just wanted to point out the problem of induction. There's a lot more to say, and the Stanford Encyclopedia article, which is in the optional additional readings, has lots more to say on the problem of induction and ways people have tried to solve it. And yeah, so Newton's approach seems like common sense, right? But then Hume is sort of trying to be much more rigorous even than common sense, right? He wants to say, why? What is it? What's the foundation? Tell me. And this is what philosophers often do, right? They want to be more rigorous than sort of common sense is. So read the SCP article if you want to know more. And in the next lecture, we're going to talk about one account of scientific method that just does away with induction, right, altogether, and says, actually, what scientists are doing is a form of deduction. That'll be Carl.